A problem like this appears very algebraic. I give you a function, and I ask you to find the inverse function, which undoes the mapping of the original function. You might already have an idea about how to solve this kind of problem, but what I want to show you is how, even without having been shown any techniques at all, you could figure out the basic idea just by thinking clearly about what it means to be an inverse. So if you remember the big idea of inverse, it's a function that undoes the action of the original function. So what is the original action of the f function? Let's imagine it step by step when you plug in a particular value. So if I was going to plug in 2, the first thing that happens is I take the square root of that input. And then the next thing that I do is I take the square root of 2 and I divide it by 5. And then the next thing that happens after that is I add 2. So there's 3 separate operations that happen. And my end result is root 2 over 5 plus 2. A number like that. Okay, so what happens if I want to undo all of those steps? All I have to do is go backwards. I do the steps in opposite order, and I undo each one. So I could start with some output, and here, instead of adding 2, if I'm going to undo adding 2, I've got to subtract 2. And then if I'm going to undo dividing by 5, I'm going to multiply by 5. And then if I'm going to undo square rooting, I've got to square it. And so that's going to give me an output that should undo whatever the input is here. So what would this look like as a function? If my input is x, for example, first I'm going to subtract 2 from my x, then I'm going to multiply that by 5, then I'm going to square that whole expression, and then I get my output. So this must be what the inverse function is, because it step by step applies the same operations as the f function, but in reverse order, and the opposite of each of the steps. I wanted to point out at the end here that that same approach isn't going to work for a function like this, because there is no single x in the expression that can be the starting place for thinking about the sequence of actions that f applies to x. So the same idea, so the inverse exists, and you can find it algebraically, but that same kind of simple approach isn't going to work.